All right, guys, welcome to the notes for circular functions. Today we're going to have two sections of notes. One will be on circular functions and the other will be on the unit circle. These notes, this outline will be uploaded to Google Classroom. The other ones you'll be taking by hand. All right, finding sine and cosine of angles. So first, just to remind you, right, the ratio for sine, the sine ratio is sine theta equals opposite over hypotenuse, and these are for right triangles. And then cosine theta, the ratio is adjacent over hypotenuse. All right, so finding sine and cosine of angles. Whoops, cosine theta is adjacent over hypotenuse. I'm going to shrink this just a bit so you can get my whole screen. There we go. All right. So it says when angles are on the unit circle. So when angles are on what's called the unit circle. So we talked a little bit about that in the last notes, but we didn't go into great detail. So when angles are on the unit circle, well, we don't know what the unit circle is yet, and I'm going to go over the unit circle. You have two options. You can either do, number one, special right triangles over and over, or number two, you can know your unit circle. All right, for those of you who are moving on to calc next year, this one, right, this is an absolute must. You must know your unit circle. And even if you're not moving on to calculus, if you're planning on taking college algebra, you're going to have to know your unit circle. So I'm going to break off here and I'm going to talk about the unit circle. So go ahead and take out a sheet of paper. You may need to pause right here. Let me just double check that my paper is in a line. There we go. All right, the first thing I'm going to do is I'm going to draw an XY axis. And first we're going to talk about increments of 45 degrees. So increments of 45 degrees, what I'm talking about is a 45 degree angle, a 90 degree angle, a 90 plus 45 would be 135 degrees. I'm adding 45 each time to my angle, and I'm actually going to grab my calculator really quickly because I might need it. All right, and then another increment of 45 is 180 and 225 and 270 and 315 and 360. So these are all increments of 45 degrees. All right, I'm adding 45 each time. All right, so in a 45 degree angle, I'm going back to a special right. It's a 45, 45, 90. So in a 45, 45, 90, what we know is that the side lengths, if the side lengths are 1 and 1, of course the side lengths are equal because the angles are equal, then the hypotenuse will be square root 2. And remember that comes from the Pythagorean theorem. All right, so if I were, though, to go to my unit circle, the reason it's called a unit circle is because the radius of the circle is 1 unit. So the distance from here to any point on the circle is 1. So I'm going to sketch in my unit circle. Hopefully I'll get a nice round circle. And if I don't, right, it's just a sketch. All right, not too bad. So that means the radius, right, R equals 1. All right, so I'm going to draw in a 45 degree angle. There's my 45 degree. And I'm going to drop an altitude straight down. And so what happens is my radius, the hypotenuse, is now 1. So if I wanted to go over here to my unit circle and I wanted to make this length a 1, well, I could divide every length, by the square root of 2. Because if I divide square root 2 by square root 2, I'll have 1. So that makes my special right triangle have a radius of 1 and side lengths of, well, I need to rationalize. I can't leave a radical in the denominator. So my side lengths would be square root 2 over, that would be 2, and square root 2 over 2. And so what happens here is that in my 45, 45, 90 triangle, by dividing by square root 2, I've now made the radius a 1. This length would be square root 2 over 2, and this length would be square root 2 over 2. All right, this value from here to here, this is called our x value. And this value from here to here, right, this is our y value. It doesn't matter in this case because they're the same, but it will for increments of 30 degrees. So the value here for x is square root 2 over 2, and for y is square root 2 over 2. But we really haven't talked about like sine or cosine or tangent yet. We'll get into that. All right, let's talk about what would happen if we were, instead of being at 45 degrees, what would happen if we were at 90 degrees? So if I were at 90 degrees, right, which is right here, if I were at 90 degrees, the x coordinate here would be 0, and the y coordinate would be positive 1. All right, let's talk about what would happen if we were at another increment of 90, which would be 135 degrees. So 135 degrees would be 45 degrees past 90. And so this angle right here would be 45, but we will have traveled a total of 135 degrees. And so you can see that these two triangles are called similar triangles. So that means that this length is still 1, and that this length is still square root 2 over 2, and this length is still square root 2 over 2. So this is square root 2 over 2, and this is square root 2 over 2. However, because we're going to the left on the x-axis, this actually will be negative square root 2 over 2. Our x value will be a negative. And so at 135 degrees, our x coordinate is negative square root 2 over 2, and our y coordinate is square root 2 over 2. So now that we've seen that really what we've done is just reflect this triangle across the x-axis, well, we could apply that same idea and reflect this triangle downward and reflect this triangle downward. The only thing that will change is our negative and positive values. So for example, right here, this would be at not 135, there's 180. We'll talk about 180 in just a second. We're going to go 45 degrees more past 180, which would be 225. So at 225 degrees, our values are still square root 2 over 2, square root 2 over 2, but this time our x coordinate is negative and our y coordinate is also negative. So both would be negatives. And if we go, I'm going to go past 270, I'll talk about 270 in just a minute. Over here to just short of 360, right, 45 degrees short, which would be 315. At 315 degrees, we would be at, this time x would be positive, square root 2 over 2, right? We would just reflect the same triangle. But y would be negative, and so it would be negative square root 2 over 2. All right, so let's go back and talk about 180. So 180 right here, this is 180 degrees, and our x coordinate here is negative 1. Our y coordinate is 0. So 180 degrees, our x's and y's are negative 1 and 0. And right here, we've already done, but let me label these. So this is 45 degrees, and this was 90, and this was 135 degrees. This was 180. Right here's 225. Right here we're at 270 degrees. At 270 degrees, our x coordinate would be 0 again, and our y coordinate would be negative 1. This one is 315 degrees, And then back at 360 or 0 degrees, we would be at 1 for x and 0 for y. And this would be 360. So those are the 45, 45, 90s on the unit circle. All right. Now we're going to talk about what sine, cosine, tangent would look like for each of those. So if I were talking about sine of, say, 45 degrees, remember sine is opposite to the hypotenuse. The opposite of this angle is our y value. So sine on the unit circle, instead of saying opposite, we're going to use the letter y over hypotenuse. The hypotenuse here is called the radius of the circle. So it'd be y over r. Again, this is our opposite, y, and this is our radius, r. And then cosine, similarly, cosine theta. I'm going to just double check that I'm not going off the screen. Yep, I am. So cosine of the angle, remember cosine is adjacent to hypotenuse. And in this case, if we're using this angle, adjacent would be this value, which is x. So it'd be x over the hypotenuse, which is r. All right, so sine of 45 degrees would be y, which is at 45 degrees, square root 2 over 2, over r, but r is always 1 on the unit circle. So sine 45 degrees is square root 2 over 2. Now they could ask you, instead of sine 45, right, they could ask you for sine and then give you a radian value. So we could take 45 degrees and convert it into radians. Remember, to do that, we multiply by pi over 180. So that would be 45 pi over 180. These would reduce to 1 over 4. So this would be the same thing as pi over 4. And so if they said, what is sine pi over 4? Right, then this would be the same answer, square root 2 over 2. Now what I'd like you to notice also, remember we talked about radians on the circle. So this was 0 pi. This was pi over 2, pi, 1.5 pi, or 3 pi over 2, and then we're back to 2 pi. So if you were to chunk this circle into, instead of just these values, right, this is 0 pi, 1/2. Well, what's right in between 0 and 1/2? 1/4. And so what you're really doing is counting by 1/4. So 0/4, 1/4, 2/4. Well, 2/4 and 1/2 is the same. This would be 3/4 pi, or 3 pi over 4. And then 4/4, which is 1 pi. 5/4, so 5 pi over 4. 6/4, but that reduces, whoops, I put 3 pi over 3. I meant 3 pi over 2, excuse me. Right, so this is 6/4, but 6 pi over 4 is the same as 3 pi over 2. 6/4, 7/4, or 7 pi over 4, and then 8/4, which is 8 over 4 is 2 pi. So really you're just counting by fourths. All right, so we've talked about increments of 45 degrees on the unit circle. Now we're going to go ahead and take a look back at some of these. So we're going to decide which ones of these are increments of 45s. So remember, these were our increments of 45s. So I'm going to highlight the ones that we're going to work on first. So sine of pi, right? Pi is an increment of 45. How do I know? I look back at my circle. Pi is right here, 180 degrees. 180 degrees is an increment of 45. 225, that was another one that was on my list, right? 150 was not. 150 we're going to have to talk about in another way, right? Cosine negative 90. Remember, negative 90 just means you're moving backward 90 degrees, which would be 270. And then negative pi over 4, same thing. if we move backwards pi over 4, backwards pi over 4 would be right here, 1/4 pi, which is 3/15. Okay, so if you know your unit circle, which I'm going to fill in my 45, 45, 90s right now, this is 0 pi. It's also 0 degrees. This is 45 degrees. And we said that was square root 2 over 2, square root 2 over 2. Oh, this was 1, 0. Let me fix that. Remember, the radius here is always 1. So the distance from here to here, our x value is 1. So 1, 0. This is 0, 1. Another 45-degree increment right here. This is, x's are negative here, so negative square root 2 over 2, and then square root 2 over 2. Right here is negative 1, 0. Right here, another 45 degrees, negative square root 2 over 2, negative square root 2 over 2. This would be 0, negative 1. And another 45 degrees would be square root 2 over 2, and then negative square root 2 over 2. All right. Now I'm going to go ahead and also write on here my degrees and radians. So this is, excuse me, this is 0 pi or 2 pi. This is also 360 degrees or 0 degrees. Right here, this is 45 degrees or pi over 4. This is 90 degrees or pi over 2. This is 135 degrees or 3 pi over 4. Again, if you are having trouble converting these, every single time you can go back and use this conversion factor, right? Convert each one from degrees to radians. And, let me scooch this over, I apologize. All right, so again, my values here, if you didn't get them, they're negative 1, 0, negative root 2 over 2, negative root 2 over 2, and so on. All right, I'm going to go ahead and finish this off. So this is pi, or 180 degrees. This is another 45 degrees would be 225 degrees. Or this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. I like doing it that way, just counting by fourths. This would be 6 pi over 4. 6 pi over 4 will reduce to 3 pi over 2. This is also 270 degrees. This is 315 degrees, adding 45 degrees each time. So we were at 6 pi over 4. This would be 7 pi over 4. And then this is 8 pi over 4, which is 2 pi. All right. Now that I have all of my 45-degree angles, I can go ahead and answer these questions. If I know this unit circle, I can just look at this unit circle and use it to answer this. So sine of pi. Remember sine, I'm going to write these down at the bottom. Sine, I'm going to actually do it up here. Sine theta, we're going to now rewrite this as sine theta equals y over r. Again, opposite over hypotenuse. The hypotenuse will always be the radius. And then cosine theta equals x over r. Again, sine, cosine. Okay, so sine of pi, sine pi would be y over r, which would be y is 0 here, 0 over 1, which is 0. Cosine is x over r. So cosine 225, I'm going to go to 225. Cosine is x, which is negative square root 2 over 2. over r, but r is 1. The next one I'll do is negative 90. Negative 90 degrees would be right here at 315. So negative 90 is right here. All that does is tell me which direction to go. It does not necessarily make my value negative. Cosine right here would be x, which is square root 2 over 2. Again, over r, but r is 1. And then finally, cosine negative pi over 4. Negative pi over 4, so if you move backward, you'd be at the same place. Cosine of negative pi over 4 is still square root 2 over 2. All right. Now these amounts right here, 150 and 210, these are also on our unit circle. We'll have to look at the 30, 60, 90s, and I think I'm going to do that on a separate video. So I'm going to pause here and go ahead and start a new video so my video does not get too long.